Hi, my name is JimSherry. I'm a projects director with Mott MacDonald in Dublin, in Ireland. I recently, with help from my colleagues, drafted a paper called Digital Engineering Enables Multinational Input on Bergen's light rail extension in Norway for the Civil Engineering magazine. I was project manager on a significant aspect of the project, but was supported by a large number of colleagues for that project. The project for us ran from 2012 to the end of 2016. It's now up and running, and we believe running successfully. This project was a follow-on to earlier phases of the same overall light rail project in Bergen. While the initial planning went on for some years, the construction of the overall light rail commenced in 2007. The original intent, and still is, was to alleviate developing traffic congestion in Bergen and to thereby reduce emissions. The aspiration with the overall infrastructure was based on the 2005 to 2025 Bergen Programme for Transportation, and that aspiration was to have the light rail system within walking distance of 50% of the houses and 80% of the workplaces. It's perhaps worth noting that the overall light rail infrastructure is part funded by a portion of the local road toll charges. The phase 1 was complete and phase 2 was underway when our phase 3 project started, and planning for stage 4 is currently ongoing, and I note that the client now requires the extended use of 3D models throughout all phases of the project.
And what was one of the key innovations in the delivery of this project?
For us, one of the key innovations was the desk-to-digger approach, which we used as much as practicable. This meant that, especially for excavation and below ground works, the engineering models were used directly for construction and in construction equipment where practicable. It was quite interesting to watch the excavation machinery and other equipment using onboard computer screens to show the actual work scope, existing services, and other aspects of the project around it. The programme for us was the appointment of Mott MacDonald in late December 2011, with the light rail system having a target of going into commercial operation in Q3 of 2016. That was achieved with commercial operation commencing on the 16th of August in 2016, and I must say that was thanks to a strong, positive collaboration environment between the client, the designer, and the various contractors. Key challenge for us was the actual logistics of dealing with the design team, which was spread across more than 10 offices in 7 countries. This spread of key resources allowed us to allocate the best resource for each aspect of the project. However, the use of digital engineering from the outset enabled the efficient working by those widespread resources. During the project, people sharing live 3D models across different offices, enabled by very good quality internet connectivity, was standard. That included working with and sharing with the client's team in Bergen and the contractors in Bergen. It was quite common for people from 4, 5, 6 different offices to be linked into the same call with the same screen sharing and different people working with and manipulating the 3D model. It was something really to be seen. Is the end product. The digital engineering was an enabling tool, but the end product is what it's all about. We believe that Bergen now has a technically excellent light rail system, and we believe that there is very good architecture and interface with the urban realm provided by that project. When you're looking at a 3D model, it's essential that you're easily able to identify and understand the provenance and the status of the different model elements. For example, primary structures could be part completed, while the detailed design for building services is still at a relatively early stage, and you're seeing all of that within the one coordinated model. For us, It was essential at the outset that we had a clear and detailed BIM execution plan, which is standard on projects like this, but it needs to be understood and adhered to by the full team. We had some initial iteration with the client to ensure that. For workflow, we used ProjectWise proprietary software as our primary collaborative and workflow tool. At the time, that was the standard in Not McDonald, and our team were fully familiar with it. The client, in turn, had a web hosting hotel where we uploaded data for him and for his use, but we needed to mimic and replicate that within our own ProjectWise system. That's part of our own quality control procedure. Another key part of the workflow was controlling the developing model. These were coordinated, clash-checked and updated at least on a weekly basis, and a clear record kept of those updates. And it was also important within the models to have clear differentiation between the ongoing developing engineering model and the presentation models, even though they're effectively extracting data from the same source. And even with digital engineering as we currently have it, change management on a project like this is critical. We used a bespoke access database to record and control all changes, whether these changes were generated internally or by the client or the contractor. The database tracked the implementation of changes through the project, through all the relevant designers and any other relevant stakeholders, and that included cost control. This was a key element to the control of the overall project. Okay. It's probably worth noting that we used Telematter for cable management. This provided a GIS-based cable tagging and routing database. It's a proprietary system used in Scandinavia, and it fed into the local council's overall infrastructure system, and we handed over to them at the end of the project, so they then owned the as-constructed data. For a rail system which is sharing the urban environment with pedestrians and with vehicles, the ability for us as designers to clearly view in 3D the interface that will happen between the moving tram and the urban environment is key. And doing that enabled us to develop a safer design, because we were able to optimize the location of tram lines, the location of structures and equipment, all to give the best line of sight both to the tram driver and to the pedestrians. People were able to see what was coming, what was happening, were clear lines, and that ended up giving us, we believe, a much safer design. Another benefit was sharing. The ability for us and the client to view, to share, to manipulate what were effectively live 3D models. Again, with the client and with the contractor, that was a significant benefit to enable the understanding, the optimizing and agreeing of the final overall design. And from a presentation viewpoint, been able to give good quality 3D presentations clearly based on the actual engineering design to end users and other stakeholders, all contributed to an early understanding of and buy-in to the light rail system overall design. And I believe that the end users and stakeholders understanding that they were seeing the engineering rather than just pretty pictures was key to their buy-in to that. The long-term goal for a city like Bergen is to continue the rollout of its overall light rail system through phase 4, which is ongoing, phase 5 and phase 6. As I noted earlier, their overall goal is to alleviate traffic congestion and to reduce emissions. And their target for 2025 is to have 50% of houses and 80% of workplaces within walking distance of the light rail system. And for a city with a population approaching 1 million, that's a significant target, but I believe they're well on their way to achieving it. And separate from that, they want, and they're achieving, a very good interface between their light rail system and the urban realm. For Bergeners, it's important that the light rail contributes to and is part of the urban realm, rather than merely just running through it as a pair of tram lines. While that's architecture rather than digital engineering, it's important to understand that that architecture and urban realm interface is facilitated by the digital engineering we're talking about.